Hello, this is Explore Post 1010 Botball. I'm Zane Zarger.
And I'm Austin Chen.
All right, here's our team breakdown. We have a gender split of 7 boys and 1 girl. We've got a ninth grader, 2 10th graders, 2 11th graders, and 3 12th graders. And we have a nice division of schools with a homeschooled student, a few students from Churchill, a few students from Magruder, and a student from Blair and Wooten each.
These are our meeting times. You can see our location there. We meet on Mondays, 6 to 9 p.m., Wednesdays, 6 to 9 p.m., and Saturday, 10 a.m. to 2 p.m.
We're organized into team captain, builders, and coders. The team captain delegates work and strategizes. The builders are assigned by the team captain to build and maintain the robots, and the coders are assigned by the team captain to a specific robot, and they focus on designing and fixing that robot's code.
When handling conflict in the team, we usually have a vote, and the team captain, if there's a tie, we have a deciding vote. For example, we're building a bot to get blue palms, and when that proved to be a little difficult, we voted together to switch to a new strategy.
We had some team goals where some team members wanted to learn how to quickly and effectively write successful programs, and some team members wanted to be able to develop better designs and effectively implement them. And all of us as a whole wanted to cultivate the ability to work as a team.
To accomplish these goals, we had more experienced members help out the newer team members. For example, those who were more experienced at Python taught newer kids who wanted to code in Python, or same thing with experienced builders teaching new kids how to mount servos and whatnot. And we had many group discussions to decide how we'll be moving forward as a group in future competitions.
So we had a 4-step strategy. Step 1 was the concept. So we decide on what tasks to complete, and then we build a claw and test them manually and discuss and decide on the base design. Step 2 was making a prototype of the bot where we would build a skeleton of the bot, attach the claw to the skeleton, and then write some basic code to test movement and claw movement. And the third step was refining that robot where we would add top hats and other sensors as needed and test as needed. And we would ensure that the robot would not interfere with anything else. And step 4 was just testing, where we'd retouch and optimize code and just ensure consistency with at least 10 successful tests.
One risk in our strategy was that we had to sacrifice stability to make our claw long enough to reach Botguy. To do this, we ended up worrying about the claw possibly breaking off because of the instability. To mitigate this risk, we added extra Lego pieces and metal pieces for stability, and the strong design does not break off anymore and is quite successful.
So one solution to a design issue was when we were initially building the bot, we had an issue with the elevation of the top hats because they were too close to the board to be effectively used. And we fixed this issue by adding another Lego piece for elevation on the front of the bot where we had our ball bearing mounted.
This is our Get Blue bot, the original.
So the original strategy for the Get Blue bot actually didn't even involve Botguy. It would go forward until it hit the black line and then grab the mineral transport and attempt to drag water palms from the bridge into the mineral transport and deliver it into the ore storage. And the original design was that the robot had a claw on top and bottom to sweep the water palms from the bridge into the container. And it was mostly made out of Legos, and it used a top hat sensor to line follow and detect black lines. So basically the original pseudocode was it would go across the board until it hit the black line, it would turn away and then back in to drag out the mineral transport, and then it would line follow until it reached the blue palms, and it would grab the blue palms and line follow until it reached the ore storage.
This is the new Get Botguy bot.
So our final design was a metal chassis using metal standoffs to stabilize and increase the reach of the claw. And some effectors were a singular hook-like claw that was designed to hook the mineral transport and knock over the cube towers, and the arm of the claw reached long enough to also hook onto Botguy so we could knock them off. The sensors we used were 2 top hats, a light sensor to start, and a button sensor to detect collisions.
You can see the design in these pictures here. You can see the claw that we designed, the front button in the front, and the top hat sensors, and the metal standoffs that would enhance the height of the claw.
So these are some test runs of the Get Botguy bot. We had 1 run where it got 80 points, 7 runs where it got about 200 points, and then 1 run where it got the maximum points that it could get, which is 350.
This is the program flowchart. You can see how our bot would pass to reach bot guy.
So this is a snippet of code to code for the line follow, which takes in a parameter time. At the beginning of the function, it sets the ending time to the current time plus the time that is passed in. And then while the current time is less than that end time, if the right top hat is on black, then it moves slightly to the left. And then if the right top hat is not on black, it moves slightly to the left, effectively creating a line follow.
For our outreach, we have an Instagram account where we post videos of our test runs and videos of us working together as a team. People who visit the Science Center where we work often look around and can inquire about our team and what we do. We also volunteer at local middle schools to help out with their club or competitions. And we also volunteer during any events the Science Center will have.
Thank you for your time.
Thank you for watching our presentation.